Alright, we're now looking at 7B.3, and in 7B.3, we're going to be using our division, okay, for two different things. Both the remainder theorem and the factor theorem. Both of these use function notation, and if you've seen function notation before, which might not have known what it's called. Function notation is a way of writing equations as what we call a function, and a function has an input and an output. So function notation is when you see it written like this. And then there's something here, right? And we pronounce this f of x. Okay? In this, we call x the input, is the input. And what you get for f of x is the output. Okay? So for example, let's say I put something like that, right? If I said what is f of 2, you just plug 2 into for x, and then you get your answer, and that's what f of x is. That's your output. Okay? So you've seen that before, most likely, but good to kind of a refresher. And then we have what the remainder theorem is. Okay? The remainder, that's what that's supposed to say. Remainder of a polynomial divided by x minus c is equal to f of c. So you make c your input, right? You can figure out, all right, what that output is by just doing division. That's what our remainder theorem says. All right, let's look at example 1. So we have f of x equals 2x to the 4th minus x cubed plus 3x squared minus 1. Again, I'm going to rewrite this. This is 2x to the 4th minus 1x cubed plus 3x squared. I have no x's minus 1. So bringing all of those down. And we're looking for our remainder. Okay. The one thing with this isn't x minus whatever. This is already what x equals. Okay, so we're taking out that one step where we set it equal to 0 and then found what x equals. It is equal to -3. Okay. And now we're doing a regular synthetic division. 2 times -3 is -6. We get -7, which is 21. We get 24, which is -72. When we multiply, we get 216. We get 215. So we have this big remainder. And what this tells us is f of whatever, right, f of -3, whatever we divided by, is equal to 215. So instead of having to plug -3 in here and having to know what all those big numbers, maybe what -3 to the 4th is and all of that, we can just do synthetic division. So in some cases it might be a shortcut, in some cases it might not be, but that is what our remainder theorem tells us. Okay. Alright, same thing here. I'm going to start by writing. I think I have to, right, but it's sometimes easier to see. 3x to the 4th, then we go to the cubed, then we go to 5x squared, 1x is 2. So we have 3, 2, -5, +1, -2. We'll figure out what we're going to put in our boxes. Okay. So we're going to be dividing by this -2. That's already what x equals. -2 times 3 is -6. 2 plus -6 is -4. -2 times -4 is +8. -5 plus 8 is -3. -2 times -3 is 6. 1 plus 6 is 7. -2 times 7 is -14. -2 plus -14 is -16. So f of -2 equals -16. Right, and that's really it for the remainder theorem. We then use the remainder theorem to give us what we call the factor theorem, which is more important, I would say. So first, what is a factor, right? We've kind of been using with our factoring review packet and stuff. So a factor is a number or polynomial. Right, we could kind of use either. That divides evenly. And by divides evenly, what we really mean is there is no remainder. So then that brings us to the factor theorem. And our factor theorem states if there is no remainder, or really you get 0, right? After polynomial division of either kind. Then the divisor, and remember your divisor is what you are dividing by, then the divisor is a factor of that polynomial. Okay. So personally, I think that polynomial, the factor theorem is very obvious. If you get a divisor of 0, well, it divided evenly. So therefore, we're saying it's a factor. It kind of just comes from knowing what the definition of a factor is, but someone was able to say, hey, look, I made a theorem, and then probably make money off of that. So now we call it the factor theorem. Okay, so let's look at some examples of this. Okay, when you're doing these problems, you're going to have to decide if you need to use long division or if you can use synthetic division. So looking at this first one, determine if 4x minus 3 is a factor of 4x cubed minus 15x squared plus 17x minus 6. Okay. This one we are going to use long division because we have that coefficient, right? So I'm going to write out 4x cubed minus 15x. Okay. So again, right, we had nothing missing. 4x cubed divided by 4x. My 4's cancel out. X cubed divided by x. There was 3 x's. I took away 1x. It's just x squared is left. We multiply by the whole thing. And again, be careful with your signs. X squared times 4x is 4x cubed. X squared times -3 is -3x squared. Okay. Now we have to change our signs. These cancel out, and we get -12x squared plus 17x minus 6. Restart. Negative 12x squared divided by 4x. Negative 12 divided by 4 is negative 3. I have 2 x's and 1 x, so I'm just left with 1 x when I take that 1 out. Now we multiply. Negative 3 times 4 is negative 12. X times x is x squared. Negative 3x times negative 3. Well, negative 3 times negative 3 is positive 9x. Doing our subtraction, we have to change our signs. These cancel out. 17 minus 9 is 8x minus 6, right, once we bring that down. 8x divided by 4x, well, 8 divided by 4 is positive 2. And then x divided by x, those cancel out, right? Multiplying 2 times 4x is 8x. 2 times negative 3 is negative 6. Change your signs. Cancels, cancels to 0. So then we can say is a factor of 4x cubed minus 15x squared. 6. Right, because the remainder is 0. Alright, looking at example 4, determine if x minus 1 is a factor of 3x cubed plus 10x squared plus 1x minus 6. Here we can use synthetic. So I'm going to rewrite 3x cubed plus 10x squared x minus 6. I'm going to bring down those numbers. We have 3, 10, 1, and negative 6. There's no terms missing. This is not a 0, so x minus 1 equals 0. Okay. So we're really, our number we're dividing by is 1. So now we're going to bring it down. 1 times 3 is 3. We get 13. 1 times 13 is 13. We get 14. 1 times 14 is 14. And we get 8. So, with this one, we're going to say x minus 1 is not a factor. Because remainder is 8. Not equal to 0. Right? Alright. Example 5, similar type of problem. Given x cubed minus 2x squared plus 8x plus 20, and that x minus 5 is a factor of this polynomial, what is the value of a? So I'm missing one of my coefficients. I'm still going to set it up the same way with our synthetic division. Okay? So I have 1, negative 2, a, and 20. Okay? Then I have my x minus 5 equals 0, so x has to equal 5. That's what we're dividing by. The other thing I'm told that this is a factor. What do we know about factors? If this is a factor, then this remainder has to equal 0. Okay, so we're going to use that idea to figure out what a is. Now that I have it kind of set up, we're just going to do our synthetic division. So I'm going to bring down our 1. 5 times 1 is 5. Negative 2 plus 5 is 3. 5 times 3 is 15. This is where it gets a little tricky. Right, I can't really add a and 15, so we just, right there, not like terms. We get a plus 15. We now have to divide or multiply 5 times a plus 15. You do have to multiply by the whole thing. 5 times a is 5a. 5 times 15 is 75. Okay, so we divide by that whole thing. Now when we add, we can only combine these two, right? Because this isn't a like term. So 5a, 20 plus 75 is 95. Okay. And now what do we know? Right, we know it's a factor, so whatever 5a plus 95 is, that has to be 0. Subtract 95. Divide by 5. A equals negative 19. Alright, let's do one more example like this and then we'll be done. Given x cubed plus ax minus 12, and that x plus 1 is a factor of the polynomial, what is the value of a? Okay. This is missing 0ax squared, right? X squared goes between x cubed and x. So I set up my polynomial, my synthetic division. I have 1, 0, 1, negative 12. X plus 1, so we have x plus 1 equals 0. So we're doing negative 1 over here. And then again, whatever our remainder, it is going to be 0 because this is a factor. So we're going to pull this down. Alright, so negative 1 times 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is 1. 1 plus 1 is... Hold on, I forgot the A. Like something's off here. This should be A. So let's go back a step. Let's see if my eraser's going to work now. Nope. That's okay. So negative 1 times negative 1 is A. This is A plus 1. Sorry about that. Sorry, this is AX, right? So 1AX. So again, bring down the 1. Negative 1 times 1 is negative 1. 0 plus negative 1 is negative 1. Negative 1 times negative 1 is positive 1. A plus 1 is just A plus 1. We're now multiplying by this whole thing. We get negative 1 times A is negative A. Negative 1 times 1 is negative 1. So combine these, you get negative A minus 13. We're just using this, so we have negative A minus 13 equals 0. We're going to add 13. Now technically there is a negative 1 here, so that's what we're going to divide by. 13 divided by negative 1 is negative 13. Alright, and that is it. I'll see you guys tomorrow.